Jackson Pollock painting, a canvas splattered with paint seemingly at random. Are you moved? Are you mesmerized? Maybe you're confused. It turns out your reaction to abstract art has a lot to do with how your brain, the human brain, accepts and interprets visual information. We feel comfortable looking at images when we can identify figures and portraits and landscapes. But a paint-splattered canvas? Our brains are having trouble with that, and thanks to my next guest, we now understand why. Eric Kandel is a neuropsychiatrist who won the Nobel Prize in Physiology and Medicine for his work studying learning and memory in the California sea slug. He's also an art aficionado, and he's written a new book, Reductionism in Art and Brain Science. Welcome back.
Thank you,
It was
Eric.
good to see you.
Pleasure to be here.
Your book begins with an observation made by C.P. Snow that is central to the premise of your book. Tell us about that.
C.P. Snow said that humanists and scientists can't communicate with one another. That is because they have different aspirations, different goals, and different methodologies. And an attempt should be made to bridge between the two of them. And I thought this period in art is one of the many examples you can use of bridges between them. Because the point is that many scientists work on problems that have humanistic value. Learning and memory, what could be more important for human nature than understanding how you learn and remember something? In addition, the abstract expressionist artists were experimentalists. Jackson Pollock, taking the canvas off the wall, putting it in the floor, experimenting with how you could apply paint in various ways. That's like a scientist. And so the bridge between the two is really much closer than people might have thought.
You're right that my central premise is that although the reductionist approaches of scientists and artists are not identical in their aims, scientists use reductionism to solve a complex problem, and artists use it to elicit a perceptual and emotional response in the beholder. They are analogous, basically, is what you're saying.
Exactly.
And do they experiment the same way with their new art that they're creating?
I don't know whether in exactly the same way. They don't necessarily keep records of every movement they make, but they certainly experiment and they see which works better, what elicits a more effective response in them primarily than in others. So it's very experimental in its nature.
Hey, your last book was about art, Viennese art.
Yes.
Well, when did you decide that art now is taking over your life?
It hasn't quite taken over my life, but even though I'm an academic and therefore have a modest salary, Denise and I have collected art from the time we were married. We have a nice collection of works on paper, so we enjoy art immensely. In fact, walking through our house every day, I get pleasure out of just looking at the art. But obviously, we go to museums a lot and we see art and we enjoy that a great deal.
So when did the light bulb in your head go off that said, oh, these abstract painters are just like we neurology professors and scientists doing sort of the same work?
I honestly can't tell a single point about this. I've been brewing on this for some time. But I like schools of thought.
Yeah.
And the Viennese were Klim, Kokoschka, and Schiller. They related to one another. This is such a fabulous group. And it was important for several reasons. One of them was that New York was not an important art center prior to the abstract expressionists. There had been some fine artists before that, but there was never a school that caught on and moved the world's attention to New York. These people did it. Mm-hmm. Fantastically important. And second of all, they gave us a new way of looking at art.
Yeah. Now let's talk about looking at art, because you mentioned in your book that there are a couple of things going on in your brain when you see art, and one is a simpler thing and one is there's a bottom up and a top down. Give me the difference between the two.
So Bishop Berkeley first pointed out, and art historians picked up on this, that when I look at your face, Ira, the images that I see in my retina are not your face, but only the photons that bounce off your face. And per se, this would be inadequate for me to perceive you the way you are. And I see you now the way I saw you a year ago and the way other people see you. So obviously, there are different sources of information. And this has been called, by Helmholtz, bottom up and top down. Bottom up is the human brain did not evolve overnight. Millions of years of evolution, and it evolved in order to adapt itself to the environment in which it lives, just like your arms have adapted itself, so your legs have adapted themselves to the terrain in which you live. So when we see a source of light, we immediately assume it's above because the sun is above us. When we see a person much larger than the other, we assume he's closer to us. So there's certain rules of perception that are built into us. But in addition, you and I have had different life experiences. We've seen different arts. We've interacted with different people. And that influences how you and I perceive a work of art.
Mm-hmm.
So even though bottom-up process may be very similar for you and me, you and I look at the same painting, you may love it, I may feel indifferent about it because of my own experiences, the associations, etc., etc. And that's what happens with a work of art. And with a figurative work of art, there's a lot of bottom-up processing. A lot of the stuff is conventional perception.
Mm-hmm. Like a portrait or conventional portrait,
right.
Something like that.
But the more abstract you become, the more it leaves to your imagination. And when you look, for example, at a Jackson Pollock, you see, dots of paint on a canvas.
Right.
You really have to struggle with it in order to see what does it mean to you. And many people, I certainly feel that way, get enormous pleasure out of little creative insights. I get a modest little idea in the lab. I put two things together in somebody's data. I feel so good for the whole day. It's a trivial insight, but I get pleasure out of it. And that certainly is true in work of art. I think insofar as your own creativity gets recruited, it's very pleasurable. And this is something Ernst Chris pointed out. He pointed out, even with the most figurative work of art, you and I look at it, we don't see it exactly the same way. What does that mean? Each of us, in looking at a work of art, is undergoing a creative experience.
And it seems like in your book you point out how the artists themselves evolved from one form of art to the other.
Amazing.
Give me your favorite example.
Take Turner. Turner, I show two wonderful images of Turner. Now this, we're talking about the 1800s. Mm-hmm. Early painting, around 1815, 1820, he shows one of his most favorite themes, ship fighting the force of nature at sea. It's rocking and rolling.
It's a real ship. It looks like a ship.
And there's no question. And you see the elements, you see the rain coming down, you see the moon, you see absolutely everything. He comes back to the same theme 50 years later, and it's very abstract. You don't see the details very clearly at all, but the effect on me is even stronger.
Because you're filling in those spots with your life experience.
And that's so satisfying. Getting your own mind involved is a very satisfying activity. The more you become engrossed in something, the more you can use your own thought processes. For most people, the more enjoyable it becomes.
Can you, as a scientist, see the mind doing that? Or understand how it fills in or brings a life experience?
Not really. Our understanding of brain science has progressed tremendously in the last 100 years, even in my academic lifetime, 50, 60 years. But we're at the beginning of understanding this enormously complicated problem. We understand how visual information is processed and things like this, and we understand where pleasure centers are and how they interact with that. We know where memory centers are, but the details of perception of art, we're just beginning to explore.
We have all these scanners, MRIs, and all kinds of stuff.
And people are beginning to look at that.
Tell me about that.
So my colleagues and I, Daphne Shahani and Celia Durkin and I, are planning an experiment. This is a fantasy at the moment. We haven't done it yet, but we're doing cognitive behavior experiments that Celia is carrying out. She's working with us. And that is to take 3 images from a given artist, one a very figurative one a transitional one, and one abstract one, and ask subjects, and on the internet you can get hundreds of subjects, to evaluate them in terms of the pleasure they get from it. And then we would ultimately like to image a population of people when they respond to 3 images from the same artist, becoming progressively more abstract, to see what part of the brain gets recruited. There is a network called the default network that is, not active under most circumstances when you're doing other important tasks. But there's some preliminary evidence that when you're enjoying a work of art and when you're involved in creative processes, the default network gets recruited. So we'll see whether or not there's some validity in this context to those kinds of ideas. But this is a virgin territory.
Wow.
This is just opening up. But it's very rich. It's similarly in music. one's response to music is so powerful. When I hear classical music, which I enjoy, I start to conduct. And I tell my wife, Denise, I made a mistake. I really went into the wrong profession. I should have been a conductor. I mean, it's the craziest emotional outburst you could possibly imagine. But it just shows you how one responds, how I respond to certain kinds of things. And people, there's a guy called Michael Shadler in Columbia. He's exploring sort of the biological underpinnings. So this is really a problem that's opening up. And it's in part opening up because the president of Columbia is very interested in these issues.
So you think you're bridging the gap that C.P. Snow was talking about?
I'm not alone in doing this, but I think that gap is being bridged by many people.
Mm-hmm. Do you think, as a scientist, that when you look at a piece of artwork, that you may have better appreciation for it because, as a scientist, you understand a little bit more about what you're looking at? I'm thinking of Richard Feynman talking about looking at a flower. He understands it better because he knows what's going on inside the flower. Also,
that comes into a very modest degree, I would say. Most of my appreciation of it. I mean, I commonly look at works of art, seeing it together with Denise, and she doesn't have a strong biological background. And our conversation is not about the amygdala or the hypothalamus, but what we see in front of us.
I save that for the class. Talking with Eric Kandel, a Nobel Prize winner, author of A Reductionism in Art and Brain Science, Bridging the Two Cultures. We're going to come back and take a break. And let me tell you right now that I went into this as a science journalist reading the book, but as Eric is such a great writer, I have gotten a lesson in the history of art. Maybe we'll get into that a little bit more about 20th century art that is so condensed and so well written that I advise you all to pick up a copy. We'll go take a break and come back and talk lots more with Eric Kandel, so stay with us. This is Science Friday. I'm Ira Flato. We're talking this hour about abstract art and neuroscience with my guest, winner of the 2000 Nobel Prize in Physiology or Medicine, Dr. Eric Kandel. And the book is Reductionism in Art and Brain Science, Bridging the Two Cultures. Our number, if you want to talk to Dr. Kandel about the brain and art and science, 844-724-8255. You can also tweet us at Sci-Fry. I want to quote something. I have so many notes from your book, so many quotes, and one of them is, our brain devotes more computational power, more bottom-up processing to faces than any other object. And you say it takes so fast to recognize a face. The brain can do that. Why? Why does it do that?
Well, there is an extensive area in the inferior temporal lobe that is devoted to faces. That was first realized in the 1940s when a neurologist had two patients that were face blind, and when they died and came to autopsy, he saw that there was a lesion in this part of the brain. This part has an anterior and a posterior part. If the lesion is posterior, you don't recognize a face qua face. You don't even recognize it as an object. Mm-hmm. If the lesion is more anteriorly, you recognize a face qua face, but you don't recognize who it is. Chuck Close is a perfect example. This is very common, this second kind of prosopagnosia, which is called. He is face blind, and the reason he developed this art style, that if he paints a portrait of you, he photographs you first, puts the photograph on the table, then puts a sheet of paper on it and begins to draw on top of it. More recently, people began to explore this. People did imaging experiments and saw that this region lights up only for faces. It doesn't light up for houses. Another area lights up for that. And then people began to record from this area. Yeah. And saw that there are cells that respond to faces. And finally, they combined the imaging and the cellular recordings, and they saw that there are face patches. There are 5 face patches in this region, and each of them represents different aspects of facial perception. And what's interesting is, underneath that, there are patches that are concerned with color, and they're interconnected. So there's a richness of representation that's available, which is quite extraordinary.
Are there certain areas in the brain that are devoted to these different places?
Absolutely. But this is an extraordinary degree of specialization, and the faces are so important.
Yeah.
We recognize each other. we recognize ourselves through our faces. Not only that, when you and I talk with one another, we enjoy each other because of the facial expressions that we share with one another. You wouldn't go into, you make decisions about going into business, doing things, selecting a partner based in large part about the facial interactions. It's extremely important for social and emotional life of individuals.
When going through your book, as I said before, you have a rich history of the New York School, as it's called here, in the post World War II era.
Right.
And you do something that I have never seen, which is you show how these artists have progressed from one stage in their life to another to become abstract artists. And, for example, I had no idea that Jackson Pollock used to do
just Midwest painting.
Midwest painting.
Yes.
Mark Rothko.
Absolutely.
You'd never look at a square again the same way.
Yes.
Knowing what happened in their lives? What happened that they moved from one to the other? Was it something different for each one of them?
I think artists are like scientists. They want to do new things. They want to perceive the world in different ways. Rothko saw that color is so rich and no one had really investigated in this detail. And when he put these bars of color together, his own response must be like our response. It's just, to me, I once sat in front of a Rothko and I said to myself, you think you're a reductionist? You are nothing compared to this. I'm serious. It was so powerful. Because a great Rothko, there are layers of the same color. So there's a vibrancy that comes through. Also, I don't know whether you've ever been to the Rothko Chapel.
No, I haven't.
In
but you wrote about it in the book.
There were about 8 or 9, I forget the exact number, major works by Rothko. He was very depressed at that period, and he soon thereafter committed suicide. Most of them are very dark colors. Some of them are black. And you walk and you see absolutely nothing at the beginning. And then after a while, you see a little sprinkling of color on the one that you're looking at. And then you feel a sense of movement. And you don't know, is the image moving? Is your body moving? It has such a powerful impact.
And you mention in the book that the reason why a lot of these paintings just have no names on them, they just have a number, right?
He moved to that depiction.
Because
you can't describe it with a name. Jackson Pollock did the same thing. Yes.
Because you're going to supply what you see.
Your own name to it. Absolutely
That's
right.
Your brain is going to fill in whatever it sees from your experience.
This is the marvelous aspect about abstract art. It demands work, but then you get the gratification of the work. It's very satisfying for the people who respond to it.
A lot of people just say, hey, my 10-year-old, as you say, could paint that. What's so great about it? But there is
Well, maybe your 10-year-old is great.
Let's go to the phones. Let's go to Fresno, California. Hi, welcome to Science Friday.
Oh, hi, Ira. My name is Tom.
Hi, Tom.
Thank you for taking my call. I thought you guys might find this interesting. I like to watch the videos from the Teaching Company, and sometime back I watched one on chaos theory. And in it, he talked about a Jackson Pollock story that somebody was trying to sell paintings that they claimed were Jackson Pollock paintings, and the buyer wanted to make sure that he wasn't getting a counterfeit. So he had some scientists perform analyses on them. So they did statistical analyses, and they found that Jackson Pollock had fractal patterns embedded in his pictures, and the counterfeit didn't. So they were able to tell that one guy was just dripping paint with no pattern, and Jackson Pollock actually had a pattern embedded in the paint.
That's wonderful. There's no question that Pollock thought enormously about the pattern. One of the reasons he liked placing the canvas on the floor, he could walk around it. And he used different instruments to drop the paint. He would use sticks, he would use brushes. So he was clearly thinking and trying different things all the time. And I think, and I'm not alone with this, he had a lot of psychological problems. He drank a great deal. He was quite depressed for a while at various times in his life. But I think one of the reasons he became so depressed and ultimately did himself in is because he felt he could not evolve anymore. Picasso had the ability to pick himself up every 5 years with a new style, either in terms of the models he was working with, or actually, playing with forms. I mean, for example, he became one of the pioneers of Cubist art, but he decided, I cannot leave figuration. So went back to figuration all the time. With Jackson Pollock, he wanted to evolve. He wanted to try something radically new. But I guess after splattering paint on a canvas on the floor, it's hard to think of doing something that is more radical than that. Mm. And I think he was depressed because he didn't see himself progressing dramatically.
I also learned from reading that Pollock was not the first to take the canvas off the wall and put it on the floor.
Indians from that area were doing this, and he saw them do it, and he learned from them. Absolutely.
Mm-hmm. The difficulty that we have with interpreting abstract art, does that mean our brains are not wired for that? Are we having a conflict with what we're thinking and what we're seeing? And so
well, that may very well be true. We certainly demand a great deal of work in looking at abstract art, and it brings forth a great deal of imagination. But look, when we look at many structures, we see vagaries in front of us. If we walk into a room and it's dark, we don't quite see what's going on. So this is not an absolutely unique situation in our experience. Mm-hmm. This is just an artistic representation of that. But there's ambiguity in life all the time.
Mm-hmm. So is it the point of abstract art then to bring our top-down experiences to the painting?
Exactly. It really gives you a chance to exercise your creativity to a greater degree than other works of art.
Mm-hmm. Let's see if we can go to the phones. A lot of people want to talk about it. Let's go to Deborah in Brownsville, Wisconsin. Deborah, are you there? Let's go to Jack in Cincinnati. Hi, Jack.
Hi, how are you?
All right, go ahead.
I was wondering if you think there was a correlation between artists being seemingly more empathic and humanistic and their use of the more, the default brain mechanisms. And if using those default brain mechanisms, they kind of align more with humanity.
I'm not sure I would say that. I mean, it's a nice idea. I had not thought of it that way. But I don't think these artists are necessarily more humanistic than other artists. In fact, you could argue that somebody who focuses, all the time on, depiction of faces may be more humanistic. I don't think that's necessarily so. I think what these artists are, number one, very experimental, and number two, they belong to a group that influence one another. I mean, one of my great privileges is to be in a wonderful academic environment at Columbia, in which there are a number of very gifted neuroscientists, and we help each other a great deal by just interacting with one another. And this is absolutely true for artistic communities as well. Pollock and de Kooning were extremely competitive with one another, but they influenced each other's thinking a great deal. And at every point, you see, the colorists, all of them were influenced by Rothko. So this is a collaborative effort. It was very much a school. In fact, many of them started out being supported by the WPA, and they were working on various projects for the public welfare, and they got to know each other and began to interact with one another.
Mm-hmm. I just want to go touch on one little section in your book that I found fascinating about the structure of the brain and where the brain, how the brain is constructed. There's an area in the brain, the two areas in the brain close together. One is for sex and one is for violence. Does that explain S&M or any of that kind of stuff?
This is David Anderson's work. It's really quite amazing. He showed that in the hypothalamus, there are two regions that are contiguous, that are right next to each other. One is concerned with aggression, and the other is concerned with eroticism and mating behavior. And at the border, there's an overlap of about 20% of the cells. And if you excite those cells weakly, you have erotic behavior, mating behavior. And if you excite them strongly, you have aggressive behavior. And it's always struck me, as it has struck you, Ira, that this could explain why certain people flip so readily from eroticism to aggression. It's a little bit scary.
Not scary talking to Dr. Eric Kandel, author of a new book called Reductionism in Art and Brain Science, Bridging the Two Cultures, on Science Friday from PRI, Public Radio International. Let's talk a little bit more. Yeah, there's so much to talk about. You write that there was a group of artists at the turn of the 20th century who tried to establish art history as a scientific discipline by grounding it in psychological principles. What claims did they make?
I love that school because one of them knew very well, one I knew slightly. He began with a guy I didn't know at all, a guy called Alois Riegel, who was a great leader of the Vienna School of Art Historians in the end of the 19th century, beginning of the 20th century. He died around 1906. He said art history is going to die unless it becomes more scientific. And the science it ought to relate itself to is psychology, and the problem it ought to devote itself to solving is how the viewer responds to a work of art, what Gombrich later called the beholder's share. Now, that's the most obvious thing in the world. I mean, any one of us would think, a painting is not complete until an artist has painted it and people respond to it. But no one had spelled this out as a specific tractable problem in art history, and no one had suggested that art historians become a little bit more scientific. Ernst Kress, a later generation of art historians, who was already getting interested in psychoanalysis, he later became a major psychoanalyst, said, when you and I look at the same painting, we see it somewhat differently. We have different responses. What does that mean? That each of us is undergoing a different creative response in seeing that painting. So that means the beholder, the viewer, is undergoing in his own brain a creative act that parallels in a very modest fashion the creativity of the artist. And as we talked before, creativity creates a great pleasure in the beholder. Gombrich, a student of Kress, began to really study this psychophysically. He actually got interested in it. And a guy called Bishop Berkeley first pointed out that how much of our brain is created by, information that is handled by the brain. That, as I told you before, when I look at you, all I see is the photons bouncing off your face. That's inadequate to allow me to reconstruct you in a way that I recognize you every time I see you. So clearly there's other information important. And Helmholtz was the one that developed this idea of bottom-up and top-down processes that have been very useful in explaining exactly how we see a work of art.
Well, when you see me, I have a face for radio, so it's good that you don't read anymore. You don't read anymore into that. So we're in just a couple of minutes I have left. Is there another art and brain book in the works, do you think? Last time you came on, you said you might be working on something?
What I'd like to do right now is do this empirical research that we're talking about, which is at a very early stage, with Celia Durkin and Daphne Shohani. We're actually considering a possible collaboration with Tom Walbart, which is a major neuroscientist interested in vision at the Salk Institute. So I would like to do some empirical work in relationship to it.
Scanning people
yes.
as they look at art.
As they look at these kinds of arts. 3 images of the same artist, different degrees of abstraction. A figurative work, a transitional work, and an abstract work, to see how people respond to it in their brain.
And would there be just general public people, anybody? Just pick them out?
We're selecting a similar group of people, let's say college students, high school students, people.
Yeah. Guys, all the graduates and universities have to go sit.
Absolutely.
We know more about...
radio announcers.
I'll be there. I'll be there. Sign me up. It's always a pleasure to have you, Dr. Kandel.
It's a pleasure to be, an honor to be here. Thank you.
Dr. Eric Kandel, neuropsychiatrist and Copley professor at Columbia University, senior investigator at the Howard Hughes Medical Institute. And if you really want a really good read, this change the neurons in my brain. Reductionism in Art and Brain Science, Bridging the Two Cultures by Eric Kandel.